Hi everyone. In today's lesson, we're going to talk about how to find the sum and product of roots to create a polynomial equation. So before we can talk about making a polynomial, we have to recall finding a quadratic equation given two roots. So remember it had something to do with finding the sum of the roots and the product of the roots? Well, the formula is x squared minus the sum x plus the product equals 0. So since we have the sum to be -2, we're just going to plug in -2 for our sum. And our product is -10, so we're going to plug that in. And we're going to simplify. X squared plus 2x, and then minus 10. I got plus 2 because I had a double negative, and I have a plus and a minus, which becomes a negative. So this would be my quadratic equation. Now it's important to note that quadratic equations will only have two roots, right? X squared equations will only have two roots. So what I'm asking you to do now is write a polynomial equation that contains the following roots. So a polynomial equation is an equation that has an exponent higher than an x squared, right? X squared is a quadratic. Now, technically a quadratic falls under the category of polynomial, but when I mean polynomial, I'm meaning more than two roots. So notice I have 1, 2, 3, 4 roots. So if I have 4 roots, my degree or my polynomial should be an x to the 4th equation. Just like I had an x squared equation had 2 roots. So the degree, the x to the 4th, will tell us the number of roots that we should have. So we're actually going to use sum and product to get the answer to this question. So we can only use sum and product for 2 roots at a time. So we can do sum and product with these 2 roots, then we can do sum and product with these 2 roots, and put those answers together to get this polynomial equation. So let's do the first ones together. So I'm going to do here root 7 and 5. And then over here, I'm going to do root of -4 and -1. So let's find the sum and the product. So sum, 7 plus 5 gives me 12. Product, 7 times 5 gives me 35. So my quadratic equation here is x squared minus the sum x plus the product equals 0. Now over here I have a sum, so -4 plus -1 is -5, and my product, -4 times -1, and that gives me +5. So my equation, x squared minus the sum x plus the product equals 0. Simplify a little bit, and we get x squared plus 5x plus 5 equals 0, right? We have a double negative here. So what we're going to do to get this polynomial equation is we're actually going to multiply this polynomial or this quadratic with this one to get a final answer. So you can use triple distributing here. So we need to multiply x squared minus 12x plus 35 and x squared plus 5x plus 5. So take a minute, pause the video, and then hit resume when you're ready for the answer. All right, this is what I got. So if you need to, pause the video and try to see where you found your mistakes, and I'm going to continue and combine like terms. So I have a 5x to the third over here, and not that one, sorry, and a -12x to the third over here. I have a 5x squared, a -60x squared, a -60x, and a 175x, and I also have another x squared here. So if I combine my like terms, I have x to the fourth minus 7x to the third plus 90x squared plus 115x plus 175. And then just don't forget to put your equals to 0, and this is your polynomial equation again, notice that my degree, highest exponent, is 4, and the x to the 4th is what we said it would be before. So just for purposes of time, I'm going to skip problem number 2, and we're going to move on to problem number 3 on the back. So problem number 3, same directions apply. Write the polynomial equation that has these two roots. Well, this one's a little tricky because there's a hidden root. You technically also have 4 minus 6i. And the reason why you have that hidden root is because complex numbers, and remember, complex numbers are a plus bi form. Complex numbers come in what we call conjugate pairs. And all that conjugate means is to switch the middle sign. So we know that if I have a 4 plus 6i, I have to switch the middle sign from a plus to a minus, and that will be my conjugate pair. Now, that is true for radicals as well. So in example number 4, we'll know there's a missing root here of -1 minus 3 radical 3. All you're doing is switching the middle sign from a positive to a negative. So it also works that radicals come in conjugate pairs. So radicals and i's, complex numbers, will always come in conjugate pairs, so you always have to look out for that missing root. So we still have to find the polynomial equation. Remember how I said you can only do sum and product with two roots? You want to be methodical about how you pick which two roots. So if you have a conjugate pair, you want to put those together. And then I'll show you how to tackle the third root in a minute, because you're not going to be able to do sum and product because you don't have a fourth root. So let's find the sum and the product of 4 plus 6i as one root and 4 minus 6i as the other. So sum 4 plus 6i and 4 minus 6i. So 4 plus 4 will give you 8. Positive 6i and negative 6i will cancel. Product means to multiply. So 4 plus 6i times 4 minus 6i. So you're going to need to do some double distributing. So 4 times 4 gives you 16. 4 times negative 6i is negative 24i. 6i times 4, positive 24i. 6i times negative 6i is negative 36i squared. Bells and whistles should be going off because I squared is equal to -1. So the negative 24i and the positive 24i will cancel. So you're left with 16 minus 36 times your -1, which is 16 plus 36, which is 52. So if we put this together, we have x squared minus the sum x plus the product equals 0. Now, in order to get the polynomial equation, we just have to take this third root here and somehow bring it into the polynomial. So if you have a single root, like you have here, you have a root of -2. All you have to do is change it into factored form. So change to factored form. So what I mean by that is if the root is x equals -2, then that must mean the factor is the opposite sign. So x plus 2. And what we're going to do is multiply that by the other polynomial and set it equal to 0. So take a couple minutes and double distribute this out to a polynomial and then hit resume when you're ready for the answer. All right, this is what I got. All right, so if you need to pause the video to try to find your mistake, please feel free to do so. If not, this is what you should have gotten. And notice the degree, or the highest power, is x to the third, and I have 1, 2, 3 roots. So the degree tells you, or the highest power, tells you the number of roots you should have. Now, if you're a little unsure as to how the root from -2 changed to x plus 2. We could talk about that more tomorrow in class. But for now, just get the general idea. All right, that's it for today. If you have any questions, please jot them down and ask us in class tomorrow. Have a good night.